Welcome to our lesson today. We want to focus on algebraic fractions today, looking at how to simplify algebraic fractions. By the end of this module, you will be able to solve exam questions that involve algebraic fractions, be able to simplify algebraic fractions as well. And as a prerequisite, if you want to gain the most out of this lesson, I will encourage you to revise your methods for factorizing algebraic expressions. Okay, as I will be treating the course with a background that you already know this. Okay, so we have our first question to deal with. We've been given 5 divided by 2 minus x, take away 4 minus x to write as a fraction in its simplest form. As in the case of arithmetic, we want to get a common denominator. So our common denominator will generally be the product of the two denominators in this case. So we have x times 2 minus x. And then you want to work out what goes on the left-hand side and the right. You will need to ask yourself some questions. How many times will the 2 minus x divide into the common denominator? And it would be x times. So you multiply that by the numerator. You do the same on the right-hand side. How many times will the x divide into the common denominator? And that will be 2 minus x times. So you do 4 times 2 minus x. Now expand your numerator. 5x minus 8 plus 4x divided by x times 2 minus x. I prefer to keep denominators the same, unless I realize the numerator would also simplify to something that I can cancel out. So simplifying the numerator, I have 9x minus 8 over x times 2 minus x. As you can see, there are no common factors, so this is the end of the question, and that's your 3 marks gained. If you, for any reason, expanded the denominator, it's also fully correct. Nothing wrong with that. Okay? All right. Next question here. This time we want to look at how to subtract algebraic fractions, but we've been given a clue as to how we want our final simplified fraction to look like. And so we're going to use the denominator of that final product as a clue as to where to start. So we know our final product will have a denominator of b plus 1 squared, so we're going to borrow that. Okay? Now, so we ask ourselves, how many times will b add 1 go into b plus 1 squared? And it's going to be b plus 1. So multiply your a by b plus 1. You ask yourself the same question on the right-hand side. How many times will b plus 1 squared divide into b plus 1 squared? And it will be 1 time, isn't it? So you do your a times 1. Okay, so expand your numerator. You have your ab, add a, take away a, divided by b plus 1 squared. A take away a gives you 0, which simplifies to ab over b plus 1 squared, which is what we've been asked to prove. So that's how you gain your full 2 marks. Okay, next example for us to look at. Now, this is fairly different from the 2 previous ones because we will need to do a little bit extra work in order to simplify both numerator and denominator before we cancel out. So let's consider the numerator. How would we factorize this? You will recall from your lesson in factorizing algebraic expressions that if we have an algebraic expression of the form a squared add b squared, we will generally express it as a minus b and a plus b. So we're going to borrow this principle to use in here. X squared is a squared number, 9 is as well. Okay, so we're going to simplify this to be x minus 3, x plus 3. Now consider the denominator of 2x squared plus 5x minus 3. Okay, our AC, comparing that to your general equation of a quadratic equation, ax squared plus bx plus c. Your a times c, so 2 times negative 6 will give, sorry, negative 3. Okay, will give us negative 6. So we're looking for two numbers that would multiply to give us negative 6, but that would add to give us positive 5. You can run through a few factors of 6 and see which one works. Seems 1 times 6 works. We need to decide which one will have the negative. Since we want a positive 5, it means the 6 will be the positive. So we'll give the negative to the 1. So we're going to then carry on 2x squared. In place of the 5x, we're going to replace it with minus 1x, add 6x, and then minus 3. Split it down the middle, factorize each section separately. X is the common factor here, 2x minus 1 on this side. That gives you a clue that 2x minus 1 will be here as well. So check what number should go out here so that if I expand, I'll get 6x minus 3, and our only option is to have 3 outside. So it means that our simplified form will be x plus 3, factorized form, 2x minus 1. Okay, so now what we're going to do is to substitute what we've factorized into the original equation. So our original equation will now be x plus 3, x minus 3, divided by x plus 3 times 2x minus 1. Then clearly you can see we have common factors. The x plus 3 will cancel out the x plus 3, leaving us with this as our answer. X minus 3 divided by 2x minus 1. Okay, so that will be how you obtain your result. Next question. In this instance, we have two quadratic expressions that we need to factorize separately before substituting into the fraction. So let's carry on and do that. X squared minus 2x minus 15. Try to factorize. We want two numbers that would, our AC in this case will be 1 times negative 15. So you have negative 15. So what two numbers will multiply to give us negative 15, but then add to give us negative 2? Okay, so we can choose 3 and 5. Which of them should be assigned the negative? Since we want a negative 2, we're going to give the negative to the 5. Okay, so that our factorized form will be x plus 3 and x minus 5. Okay, right. Having done that now, we can carry on to the second one. So we have 2x squared plus 7x plus 3. Again, same scenario. A times c is 2 times 3, which is 6. So we're looking for two numbers that would times or multiply to give us 6, but then that would add to give us 7. So what two numbers come in your mind? 1 and 6. Okay, if that is the case, then well, both are positive, so we don't need to assign any negative numbers. So we go 2x squared, add 6x, add x, add 3. Split it down the middle, factorize each section separately. It means that there will be x plus 3 here, and it means there's a 1 outside. So we have 2x add 1, and then x plus 3. We'll then substitute everything into our original fraction. So we have x plus 3, x minus 5, divided by 2x add 1, x plus 3. X plus 3's cancel out. Final answer as a single fraction, x minus 5, 2x add 1. Okay, excellent. Shall we move on now to our final example? I think this might be a repeat question, so we ignore that. We have this one that involves division. What would we do? Now, first thing you'd like to do is to recall what you do when you divide fractions. You will recall that if you're multiplying any two fractions, say a over b divided by c over d, you repeat your first fraction, you change your division to multiplication, and then you write CD in its inverse form, so d over c. Okay, so I call it keep, change, flip, KCF. So you keep the first fraction, change your division to multiplication, and then flip the second fraction. Okay, so you might have your own way of recalling it, but that's fine. Anything that works for you will be acceptable as long as you apply the correct principle. Okay, so what I'm going to do here now is to keep our first fraction, so 3x add 6 over x squared minus 3x minus 10. Change, so it's keep, change, flip, yes? So change our division to multiplication, and then flip our second fraction. Next, we want to now concentrate on factorizing each individual term. So the numerator there would simplify to 3x plus 2. Our denominators, now referring to the previous slides, we want to find two numbers that would multiply to give us negative 10, but then add to give us negative 3. So 5 and 2 come to mind. So we have x minus 5 because we need a negative 3, and then x plus 2. Okay, this will be multiplying. If we factorize the numerator there, okay, divided by x plus 5. Going forward, we can simplify that, okay, but guess what? X squared minus 25, what do we have? Differences of two squares. So we can rewrite this as x times x minus 5, x plus 5, all divided by x plus 5. X plus 5s will cancel. X minus 5s here will cancel, leaving us with 3 times x, which is 3x. Therefore, our A is 3, based on what the question is requiring. Okay, so I hope this lesson was helpful to you. If you have any questions, please drop me an email. Otherwise, all the best with your preparation for your exam, and then have a good day. Bye.